Bump testing of gas detectors is something that every Rescue 3 instructor should take their students through on whatever course you're doing, and therefore we need the correct equipment and a little bit of knowledge of how to do it. In a separate video I've explained how to take the thing apart and look at the sensors and check and change the filters. Right, so go and watch that video if you don't understand any of that. But bump testing is the only way that we can verify out on site that all of these 4 sensors are working. When you do your fresh air startup, which of course you need to do outside in clean air, you will effectively auto zero the oxygen sensor, which is this one here, because that's the sensor that is constantly consuming itself. It's usually seeing oxygen all the time, so it goes out of specification. It's an electrochemical sensor, so you just reset that on startup by the auto zero process. And then the other 3 sensors on here, so your flam sensor, your carbon monoxide, and your H2S sensor on this particular gas detector. All right, your test, the gas detector will test that the circuit's working, but it won't tell you how accurate these sensors are. So the only way you can do that is with a bump test. And so you should be taking students through how to do the bump test. To do the bump test, you will need a calibration gas that is set up for your particular gas detector. And you just talk back to your supplier, all right, unless you've got this software to go in and find out what this gas detector is set to, and they will then tell you which, or supply to you a quad gas so that you can do all 4 sensors at once. So we've just used Rockall here, local supplier to us, to provide a quad gas that's set up and has got the same concentrations of gas in here as the set points for the calibration on here. You can find that from all the software. Okay, so this particular one is set up with hydrogen sulfide at 25 parts per million. I've written it up on the screen at the back so you can see it. All right, the carbon monoxide in here is at 100 parts per million. The LEL sensor, which is calibrated off methane on this detector, so 2.2% volume of the air is 50% of the LEL for methane. Okay, and then oxygen is in there at 18%, the balance being nitrogen. So these cylinders are relatively expensive. Okay, you're talking north of 100 quid to buy one of these. They come in different sizes. They do go out of date. All right, so you should track them within your own system. So we just use paper trail for that. All right, but you've got your gas detector, your gases. What you'll then need is a suitable regulator to go on it, and you'll need suitable hose to connect your regulator. Excuse me. To the shroud that will have come with your gas detector when you got it. To assemble this system, what's important is that you open the regulator so that you don't accidentally push and burp some air into here, because the air's got water vapor in it, and water vapor will bind with the H2S that's in there and upset the readings. It's a very fine thread, so take a bit of care to get the thread started correctly. Check your valves open and then just screw the regulator on. As soon as it's on, you can shut off the valve. All right, this is very vulnerable, so if students stand this up in the classroom, inevitably it's going to fall over and you'll either crack or damage that. All right, so assemble your resources and have some kind of thing that they can just put that down on so they can use it. It's not going to fall off the table and they can see the regulator. Your gas detector would have been turned on outside in fresh air, and it wants a couple of minutes just to stabilize itself. And then it's just simply a question of plugging the shroud over the top of the gas detector so that when you show gas to it, it's going to flush all the sensors. All right, make sure you've got a copy of these numbers here somewhere, because you can do more than just basically test that the sensor is going to react. All right, so by looking at these numbers and seeing how long it takes for the gas detector to stabilize to these numbers, we can get a sense of how clean the filter is and how healthy the sensors are themselves. But we'll just go ahead and do one. So I'm going to turn the gas on, and you can see almost immediately the gas detector starts to react. And what I'm looking for is how quickly they get to these numbers. So my oxygen sensor is at 17.9 and I'm looking for 18. My LEL sensor is already at 47 and I want 50%. CO is at 97 and I'm after 100, and my H2S is at 23.2, so that's, no, after 25. So that's the one that's out a little bit, but all the others have got there pretty quickly. The H2S is just slowly creeping up there now. All right, so I'm happy that all those sensors are working. I turn off the gas supply because it gets a bit stinky after a while, and then I can detach that. I've now finished with this. Make sure you train your students that after you've bump tested in the morning, they take this regulator off the gas cylinder. If they leave it on and leave it slightly open, you'll empty this cylinder, and you'll regret that because they're expensive to replace. So we set our gas detectors to latch, so as soon as I cancel the latch on here, the numbers should go back to normal with a possible lag on the oxygen. It takes a little bit longer to reset. So there you go, everything's gone back. The oxygen's sitting on 20.4. Sometimes these will reset, and sometimes when you clear them, they'll bump back to 20.9. Okay, it's really important that once you've done that test, you go into the peaks, and on here, you just double tap to go in. And you go round and you can see that we've got some stale values, okay, and then we've got our peak values, and then we clear those. So when it says reset, you press those and clear those off. That gas detector is bump tested and ready for work. I've turned it off because it's just annoying, the little chirp in the background. So what do we do with this information? All right, the numbers that you got on here in terms of how accurate the gas detector is against the reference gas should be within 10% of the reference gas values. Otherwise, that sensor is out of spec. You can then bring them back, hopefully, by doing a calibration on site, and you can do that with exactly the same gas and exactly the same equipment. You just need to know how to calibrate it. That's all end user functionality. And again, you can show the students an example of that if one of your gas sensors is a little bit off. All right, we record the bump tests, and you should be encouraging students to do a bump test and then to record it. Some organizations just put the date and the gas detector number and then just pass. All right, what we have is we have a sheet on ours, and so they'll actually write in the numbers that they see on the screen when it's stabilized. So we've got a complete record of how this gas detector is performing on the day when it was bump tested. All right, and I think that's good practice to show students that and encourage them to do it on each morning of the class. If you haven't got that record, the gas detector itself will have it. So on the circuitry in here is a memory system, all right, and so that'll all just be logged on the data card, for want of a better fashion. And if we then later plug the gas detector in, we can download all of that data onto the Fleetware software, all right, and that can then be available for our records, or typically to go out to clients if they need that. All right, so everybody should be bump testing, so we need to show them that and talk to our students about why it's important to bump test. It's helpful for them to see inside a gas detector so they understand the mechanics of what's going on, particularly at the rescue level courses as opposed to just the sort of like the one-day introductory ones. They certainly need to have some awareness of the filters. All right, so for us as instructors, we should be really familiar with all of this and have the correct equipment. The last thing I want to say is sometimes the gas on these older cylinders, as they start to wear down, particularly the H2S gas, goes off slightly because it's got some water vapor in there, especially if you've been using the cylinder on training, because students don't necessarily always open the valve when they do it. So it's good practice perhaps to have a separate cylinder, which is a new cylinder, which you don't use on training, all right, but you keep that for when you're calibrating, and then you know that the gas mix inside here, particularly the H2S, is going to be in really good condition. All right, and so when you're calibrating and resetting the curves back to what these should be, it's better done with a fresh cylinder. Okay, you can get all of this through your local supply chain. If you're hiring in your detectors for training, then it's probably better to make sure that you just get one type of detector. So this sort of like setup and this understanding and this functionality is available across all of the different brands and models. So there really is no excuse for not doing it with students on training. Okay, thank you.